Hello, my Calc 2 student. Today we talk about inverse trigonometrical function and differential dysfunction. This is very important part. Will be carefully and listen me, please. Okay, we start. How you remember a function invertible if is one-to-one function? How you remember trigonometrical function is periodically function. It cannot be one-to-one. Because if you take it any kind of, for example, sine, and continue, if you take it any horizontal line test, any horizontal line intercept our graph infinity times. It's not more than one, it's infinity times if your line stay between -1 and 1. Exactly. But for trigonometrical function, because it's very important function, we need inverse function. And what we're doing? We take some piece function and then build inverse. What about piece? What criteria we take it? First, we need some piece where is covered all range. Second, it will be great if our piece will be close to 0, because close to our ordinary, close to our very important point, x equals 0. And how we can do it? For each function, it will be different interval, but I think we can. First, we're doing about, take it for sine x. If you remember, graph, let's go, this is x, this is y, and I put very important point. Let's go, it will be pi over 2 and negative pi over 2. And my graph sine x between negative pi over 2 and pi over 2 covered all value range, because from negative pi over 2 it will be -1, and for pi over 2 it will be 1. Remember, this is function sine x, y equals sine x. Great, this means we have very good piece. Domain, this piece of function, you see, we have like different domain and not domain for whole sine x. Domain will be some interval between negative pi over 2, pi over 2, and include, and range will be something between -1 and 1. How we remember inverse function, graph inverse function is will be symmetry for line y equal x, and domain in range for inverse function is switch. Great. Now I try build my inverse function. What I have? I have between -1. Oops, sorry, what? Let's see. Between -1 and 1. All right. And value, it will be between negative pi over 2. Okay, I'm doing something. Here it will be negative pi over 2. Here it will be pi over 2. Right? And now we build our graph. I'll use different color. It will be something like this. Okay. A red graph will be inverse graph for a function, for black one, for a function sine x. For all trigonometrical function, inverse function have its part arc. This means for sine, this will be arcsine. For cosine, this will be arccosine, arctangent, and continue. This means my red graph, it will be y equal arc sine x, and domain for red graphs, it will be from -1 to 1, and range will be from -π/2 to π/2. Doing some example. For example, I need to evaluate what will be arc sine 1/2. This means I need found angle. I think I move from black writing. I need found alpha such as sine alpha equal 1/2, and alpha need be from -π/2 π/2. How you could remember table? It will be alpha, it will be π/6, right? This means arc sine 1/2, it will be π/6. Okay. Try build inverse function for cosine x. Remember, we need to take it some interval where cosine x covered all range. This means value, all value between -1 and 1, and some interval close to 0. I think we have from 0, this will be π/2, this will be pi, and let's go, it's -1. And I have something, oops, oh my god, my graph is very scary. This is pi. This is graph, piece of graph cosine x, y equal cosine x. And how you can see, this part is 1 to 1. Domain here is from 0 to pi. Range here is from -1, 1. What I can do it? Okay, what this will be inverse function. Okay, change color. And we now domain and range switch. And this means our domain now from -1, -1 to 1, and value it will be until p. This means I use how it's counting, looks like correct. You remember p is 3.14. This means it's 3 times longer than what I have here. Let's go, this is will be π/2, and this is will be pi. Okay, I have point for my graph. The point is 0, 1. This means now new point is will be 1, 0. For inverse function, this will be 1, 0. I have point π/2, 0. This means now I have 0 π/2, this one, and then I have point pi -1. This means I have -1 pi. And remember about symmetry. This means shape. Oh my god. Okay. Believe me, something like this. And remember about domain new function. Domain is -1, 1. Range is from 0 to pi. We have 4 more elementary trigonometric functions. For tangent and cotangent, I think it's simple. Take it some part-varies function between two asymptotes. Okay. For tangent, you have two close from 0 vertical asymptote. This will be negative pi over 2 and positive pi over 2. And this will be graph. And this is y equal tangent x. Okay, here, if you build something symmetrical, this means your two vertical asymptotes move to two horizontal asymptotes. This means you have two horizontal asymptotes, pi over 2 and negative pi over 2, and your inverse function will be something like this. I think it's first example for our practice when we have function whose have two horizontal asymptotes. Okay, this means y equal arc tan x. No, I'm sorry. And domain inverse function will be from negative infinity to infinity. Range will be from negative pi over 2 open interval to pi over 2. For arctan, sorry, we remember about close to piece. It will be, I think it's piece from 0 in pi. Here's two vertical asymptote. One is x equals 0, second is x equal pi over 2, so will be 0. Oh my god, sorry. Usually I make it much better, believe me please. And we have two horizontal asymptote for inverse function. One is axis x and second is y equal pi. And here is, we build symmetry. This means we have point, our point is pi over 2, 0, move to point 0, pi over 2. Okay, and if our part, how you remember x approached to 0, y approached to positive infinity, this means if y approached to positive infinity, you have this part. I'm trying to make it, and here we have something like this. For graph y equal arc cotangent x, you have domain negative infinity, positive infinity, and range, it will be from 0 to pi, open interval, because this is two horizontal asymptote and never intercept. Okay, never reach. And now we have two more complicated situation where you have secant and cosecant, and we need build our inverse function. Okay, try first. I think it's for cosecant situation. We're doing step by step and then see what we have. Okay, first I draft my graph as cosecant x. What we're doing, how you remember, we need build sine x then every time where your graph intercept axis x, you have some vertical asymptote, and then graph will be touch in the maximum blue one is graph cosecant. What I write cosecant, sorry. Okay. Y equal cosecant x. And now question. I need take it some piece of my function, whereas it will be close to 0, close to our point, and close to origin, and covered all possible range. I think we can see it will be part between, okay, here's negative pi over 2 and pi over 2. What's the situation? This means we take it some part of here and part of there. Okay. Move there. This means I have something. Let's go. This is pi over 2. This is negative pi over 2. Here is will be 1. And this is will be negative 1. Here. What you know about domain and range? Domain, this function is from negative pi over 2, pi over 2. Without 0. I think it's maybe better if I write like 2 part 0 and 0 pi over 2, and range will be from negative infinity, negative 1 include, and from 1 to infinity. You see how complicated part of cosecant x we take it. And what happened with inverse function? Range and domain change, graph will be symmetry, and I can do it. It means I have 1 here, 1, I think it will be there, pi over 2 it will be there. Okay. Point is will be here, and symmetry go to there. This is part here. This will be and for a red graph will be y equal arc secant arcsecant, sorry. What you say about range and domain? Range, domain, it will be from negative infinity to negative 1, and negative 1 include from 1 to infinity, and range will be from negative pi over 2 till 0, 0 not included, 0 to pi over 2 included. You see how interesting function we have. Okay, for secant we take it in this part. I'm not built with some step-by-step all function, but I'll write for you. You can do it yourself. And here we have, okay, it will be pi over 2 our vertical asymptote. Here is will be here, and this is will be there. Okay, this point is will be pi. This values will be negative 1, value 1. This is our y equal secant x, and build our inverse function. We can see pi over 2, it will be our horizontal asymptote. Okay, and how it's work our graph. Point 0, 1 move to point 1, 0. Okay, and try and make reach our horizontal asymptote, and our point, for example, pi negative 1 is moved to point negative 1 to pi. Let's go pi, it will be here. Oops. And it will be this part. And domain, our new function is will be from negative infinity to negative 1, and from 1 to positive infinity, and range will be from 0 to pi over 2, and pi over 2 to pi. From 0 include pi over 2. Pi over 2 is horizontal asymptote. This means never intercept, never reach. Pi over 2 to pi include. Okay, great. Now we give definition and see graphs all our 6 inverse trigonometrical function. Try doing something how we can evaluate something. For example, what will be arc? Oh, black one. Okay. Arc 10 square root of 3. Here we need to remember angle, whereas tangent is square root of 3, and angle stay between 0 and pi because it's our range for inverse arctangent function. How you remember? This will be pi over 3. Great. One more example. I have angle alpha. I know about this angle is arc secant square root of 5 over 2. Question: found tangent alpha. Great. Now we go for our lovely right triangle. Let's go one if angle here is alpha. What kind of information about this triangle you know? You know secant alpha is square root of 5 over 2. This means hypotenuse is square root of 5 and this side is 2. Use Pythagorean theorem, you know this will be square root of 5 squared will be 5 minus 2 squared will be 4. It will be exactly 1. And now you can tell tangent alpha, it will be 1 over 2. You see, we use triangle and we can find. Great. Now question, how we can find derivative of inverse function. Okay. We have some theorem one who give us 6 formulas. Okay, derivative dx from arc sine x. I think I write this arc sine u when you can see what happened if you have inside something more complicated than simple variable. Arc sine u, it will be u prime square root 1 minus u squared. If you take a derivative arc cosine u, it will be minus u prime over square root 1 minus u squared. You see different only with sign. One is plus, one is minus. Okay. Arctangent and arctangent pair. D for dx. Arctangent u. It will be u prime 1 plus u squared. And derivative arctangent u, it will be u prime minus u prime 1 plus u squared. Arcsecant and arcsecant, our last pair. Secant u, it will be u prime absolute value u square root u square minus 1 and derivative here. It will be minus u prime, absolute value u, square root u squared minus 1. Okay, great. For proving, I think we prove first of them, and situation when it's our variable, it will be a simple x, because if you have something u there, it's use chain rule. And okay, I need found derivative arc sine x, question mark. How it's easy doing? Alright, combination function and inverse function. This means we now composite sine arc sine x, it will be exactly x. Found derivative, both sides our identity. Derivative sine, it will be cosine from arc sine x. It will be multiplied by derivative inside function. We use chain rule here. Derivative arc sine x, and it will be equal 1 because derivative x is 1. This means what kind of situation we have? We have derivative arc sine x. It will be 1 over cosine arc sine x. Great, but not useful. We try go to back for our function. Okay, how we can do it? We have arc sine x equal y. Use our triangle. We know it's mean if you have angle alpha here. What does mean arc sine angle y here? Sorry, angle y here. This mean sine y equal x. This mean opposite side is x, hypotenuse is 1, right? Right. What is will be cosine from y? It will be, we need found third angle, it will be 1 minus x squared. It will be square root 1 minus x squared over 1. This means square root 1 minus x squared. Plugging this information for our formula, what we prove, we have arc sine x derivative, it will be 1 over square root 1 minus x squared. Pretend inside arc sine we have something more complicated. This means we have some function u here. Derivative will be first doing how we doing derivative arc sine. This means square root 1 minus u squared and multiply by use chain rule derivative u. It will be u prime. We prove first of our formula, and all other we use absolutely same technique, and we can easily prove it. Okay, doing some examples. How I can find derivative arc sine square root of x. Denominator will be square root 1 minus square what we have inside arc sine. This means square root of x square. Numerical will be derivative from your square root of x. Okay, it will be 1 over 2 square root of x. This means here, if you write normally, it will be 1, 2 square root of x down, and here you have 1 minus x. What happened if you need the found derivative arc tangent 5x? It will be the denominator is 1 plus square function what you have inside arctangent. This means 5x squared. And numerical, it will be derivative 5x as 5. This means here we have 5 over 1 plus 25x squared. One more example. Found derivative arcsecant e exponent 2x. Arcsecant e exponent 2x. Okay. How you remember? Denominators will be absolute value what you have inside, but because e exponent, oh okay, I'm right formally what we have here, times function square minus 1. This means e exponent 2x square minus 1. And numerical, it will be derivative e exponent 2x. It will be twice e exponent 2x equal. Here, first, remember exponential function always positive. This means you don't need absolute value. This will e exponent 2x. Here is twice e exponent 2x. Here is root e exponent 4x minus 1. Cancel it, and final answer is 2 over square root e exponent 4x minus 1. Okay. Now I'm showing you a couple of examples to help you doing your homework for this section. First, question number 22 in your book. Found tangent arccosine square root of 2 over 2. Here you can use triangle or, oh okay, we use triangle or remember table, let's say. Okay, let's go, we need found angle alpha. And because cosine, this angle is square root 2 over 2, this means here you have square root of 2, then you have 2. And found opposite side, which give us 4 square root 4 minus 2, it will be exactly square root of 2. Tangent this alpha, it will be square root 2 over square root 2, which means 1. Okay. Second question from second part of question for number 22. Here you need to evaluate cosine from arc sine 5 over 13. Use same use triangle. Let's go, this is angle alpha. This means sine this angle alpha is 5 over 13. This means opposite side is 5. Hypotenuse is 13. This side will be square root 169 minus 25. 144. This means 12. What is cosine? This means adjoint 12 over 13. You see, practically we only remember our triangle and plug correctly our data. Okay. Two more questions. I think it's 3 more questions I show you from similar your homework. Number 48. Here we need found derivative function. Fx is arc sine x plus arc cosine x. Derivative will be derivative arc sine 1 over square root 1 minus x squared. Derivative arc-cosine minus 1 over square root 1 minus x squared. Its mean is equal 0. It means sum arcsine plus arccosine is always constant because derivative is equal 0. Great. Number 54. Here you have function arctangent 2x, tangent 2x minus 1/4 natural log. Here I think we don't need absolute value because it's always positive, because here I have 1 plus 4x squared. And we need found derivative here. Okay, y prime will be derivative arctangent. Denominator is sum 1 plus square what you have inside arctangent. This means 4x squared. And numerical is derivative what you have inside arctangent. This means derivative to x. This means only 2. Great. Ooh, I think when I doing, I forgot, I'm copy, sorry. We do it absolutely right, but when you take it number 54, we have x time arctangent to x. Okay. Because I first found derivative arctangent to x, this means multiplied by x. Plus derivative x's will be 1, and here we have only arctan to x. Here we have product rule, and we do. I only forgot about right x. Okay, and second term, this means derivative natural log. It will be minus 1/4 natural log. Denominator what you have inside log 1 plus 4x squared, and numerical derivative what you have inside log 1 plus 4x squared. Derivative it will be 8x. Okay, simplify. First fraction is 2x over 1 plus 4x squared plus arctan to x, and here is cancel it, and here we have minus 2x over 1 plus 4x squared. This means this two fraction is cancelled, and final answer we have arc 10 to x. Great. Oh, I think one more question is question when we need found equation of tangent line. We're doing something like this. Y equal 3x arc sine x 1/2 0.1/2 with coordinate 1/2 pi over 4. Here we need found slope our tangent line. This means our derivative will be, here's product rule because we have product to function 3x and arc sine x. Derivative 3x is 3 arc sine x plus 3x 1 over square root 1 minus x squared. Plugging here is 1/2. We have arc sine 1/2, it's pi over 6. This means you have 3 times pi over 6 plus 3 times 1/2 and over 1 minus 1/4. This means 1/4. This means here is 3/4. Square root is 3/4. And if we simplify, we have pi over 2 to go up and to cancel it, and I think we have plus square root of 3. This is our slope. If you have slope, this means y minus value your second coordinate, your points, is pi over 4, equal slope is pi over 2 plus square root of 3 multiplied by x minus 1/2. Here we can little bit simplify. We have y equal pi over 2 plus square root of 3 times x and minus pi over 4 minus square root 3 over 2 and plus pi over 4. Cancelled. And final answer is will be pi over 2 plus square root 3 x minus square root 3 over 2. Okay. Guys, we need unit more practice for found derivative inverse trigonometrical function because it's very, very important part of our class and very useful. Okay. Good luck with homework, and if you have any question, we have Thursday office time for Zoom, and I think we covered all your questions.